I've always been told that in order to get really good tone out of your tube amp, you have to crank the output stage. What is actually going on? What are the real differences that are happening when you turn the volume really, really loud in your guitar amp? That's what I wanted to figure out. And most importantly, what this all means is you're going to learn how to set up your amp to get the best sounding guitar tone for your music. And one other thing I want to mention, I'm not just doing some dumb sine sweep analysis that's not really realistic. We're going to actually be using DI tracks that were recorded of an actual guitar performance that's run through the amp. That way, what we're looking at is the most realistic interpretation of what goes on in the power section of those amps. Now, where I think this video is going to add so much value is I'm going to show you both the listening tests, and then we're going to peek under the hood, do some science, and see what the difference in the actual spectra are that I've collected from these waveforms. To do this properly, I had to pick up a load box to dissipate the energy from my tube amp, which is a Marshall TSL-60 I have sitting back here right behind me, right there. That allows me to take the direct signal straight from the back of that tube amp into my interface. Just a few quick caveats that I want to go over. I did 2 different gain settings on my guitar amp. I have a low gain that just has a little bit of slight breakup on the lead channel. And then I also did a high gain setting so we can see if there's differences in the output section depending on how hard the preamp is driven on the guitar amp as well, because I don't know. That's something I wanted to figure out. I also have the output stage set to 4 different levels. We have a low volume, a mid volume, a high volume, and then maxed out at 11, baby. This is where the meltdown happens. Now, as I mentioned, this is straight out of my tube amp. There is no impulse response or cab simulation, and that is why it might sound very fuzzy and fizzy and kind of unnatural. I've normalized these files 2 different ways. One is by root mean squared. That's going to give us the average power. I used these files when I did my analysis. Now, the reason for normalizing the RMS levels is so we don't get a bunch of plots that just shows louder is better. They're going to show us the tonal and dynamic changes that are actually occurring with the guitar tone. But for our listening tests, I've normalized this set to have the same LUFS value. LUFS, if you're not familiar, it's weighted in a way that is representative of human perceived loudness because we want to minimize bias. Also, for all the plots I'm showing, it's not just a snapshot in time. It's actually the entire guitar performance that I've analyzed and averaged. And one final disclaimer is that when I'm talking about harmonics or distortion, I'm not talking about a lab-certified THD or total harmonic distortion number. I'm talking about musical indicators here, which is far more practical for a guitarist. I want to know what changes in the real guitar performance, the pick attack, the sustain, any fizzy characteristics, the low mids. So let's first start with the frequency differences that we see at these different volume levels. Y-axis is, you could think of this as basically the power, the level of the guitar signal per frequency, which is along the x-axis here. 10 to the 2 is 100 hertz. This is 1,000 hertz. And 10 to the 4 is 10,000 hertz. When we're increasing the volume from low, which is blue, to mid volume, we start getting a drop off of the top end. From mid to high, we're losing more top end, but everything else seems to be pretty consistent. Then when we turn it up all the way to max output volume, we start seeing a complete shift in the tonal characteristics of the guitar amp. A lot of this top end starting to creep up. We also see an increase in the upper mid frequencies right here. So it's starting to thicken out in that mid range. Super interesting. Let's take a look at the high gain setting. So this is with the gain on the lead channel set to about 75%, and then the different volume at the output stage. Blue is low volume, middle volume, high volume, and then max. But we have some very interesting trends that are actually different than we saw before. The lowest gain setting is actually the brightest guitar tone. With mid volume, we start getting a roll off of that top end. Right when we get to high volume, so that's at 75% output volume, we start seeing the mid-range creep up right here from about 300 hertz all the way to about 900 hertz. So we're starting to get this like mid-range bump coming out. And then we also start getting a huge loss in these high frequencies. And then when you crank it all the way to max volume on the output stage, that's when we actually see a little bit of tightening up of this sub-frequency here. We're getting a continuous drop off. And then we see the most pronounced bass in mid-range output. So our red trace is the max volume. And we get a big jump right here, again, between like 600 and 900 hertz. Again, that's thickening out that guitar tone. And then also rolls off the fizzy top end. So here are the plots side by side. Again, this is low gain and high gain. So this is proof right here that turning that output stage is going to change the frequency content of your guitar tone. So if it didn't matter, all these plots would look exactly the same, and it would just be louder or quieter. But that's not the case here. This tells you that guitar amps are non-linear. They might do certain things in a certain way up to a point, and then when you start driving them too hard, they might do some very strange things. So you might be wondering what's causing that. So something very interesting about the output stage of tube amps is that if they're driven too hard, they can actually go into clipping. And the transformers can add some saturation to the signal as well. And there's also something called rectifier sag. It's actually a temporary drop in voltage to the power section, which can happen when an amp struggles to deliver enough power. So that previous graph was a little bit hard to read. So let's take a look at the difference spectrum, which is going to make these changes much more obvious. This is like the money graph to prove that there is some big changes going on when we start changing the output stage on our guitar amps. So starting off with the low gain, anything above 0 means that we have a stronger signal compared to the low volume recording that we did. Anything below it means that it's weaker in those frequencies. Okay, and everything is in reference to the lowest volume setting on our tube amp. So as we go from low to mid volume on our output stage, we start losing high end. At the high level, we start losing a lot more high end, and then we start seeing a little bit of a bump in the mid range, just like what we saw earlier. And there's actually a little bit of a tightening of these like bass frequencies around 100 hertz. But then when you max it out, something breaks down inside the amp and we start getting a lot of high frequency content. This might be construed as fizzy. And then we also get that mid-range bump. It's like 650 hertz. And there's also a little bump right down here at like 300 hertz. And these subby frequencies, which keep creeping up, if I had to make a guess, it's probably something to do with the transformer. All right, if we look at the high gain settings, this is pretty wild. We get a much more pronounced and more consistent bump in the mid-range. It's like 3 dB compared to low volume setting. And in some cases, we're getting almost like 12, 13 dB of loss on that fizzy top end, which is just super interesting to me. And this is why it's so hard to describe what actually goes on with the power amp sections of our guitar amps. In some cases, when you push it really hard, it seems like the top end rolls off and then it kind of recovers. Or you might get a pronounced mid-range, but it might not always be in a linear way. It completely depends on how hard you're driving that output to determine if you're going to get more mid-range bump or if you're going to get a fizzier or softer top end. This is basically that last graph I showed you, but it's broken into these little bands now. So the bands I've set up so that you have some mixing context. Goes from low volume to mid, high, and then max. And then this particular graph I'm showing is the high gain setting. So as we increase the volumes, we get a lot more low mids. This green bar keeps increasing. So as you drive it, we're going to add some weight and thickness to those guitars. If we take a look at the low energy, we see that's fairly consistent. That's that orange band. Okay, it seems to be creeping up slowly. And then once you go from high to max volume, it actually drops a little bit. Okay, so we're losing some of the low energy. So if you're doing a lot of 8-string, 7-string stuff, it might not be great to drive your amp super hard because you might roll off some of your low energy. If we look at the mids, right on 350 to 800, this is going to be kind of a boxy sound. As we go from low to max volume, it actually keeps increasing. So you might need to carve out more upper mids if you are using high output levels. Fizz and air seems to be predominant at the low volumes and then a hard drop when you start really pushing it. I think this is really important for modern rock and metal productions to be aware of this, especially if you're using real amps. You might want to drive it harder to kind of tame that top fizzy end, which is really annoying. A lot of this can come out naturally when you actually run the head through an actual guitar cabinet, and then good mic choice and mic placement technique can actually fix a lot of these issues. Remember, this is just the sound coming straight out of the guitar head. So the high and max volume might feel a little bit smoother coming out of the amp when you're recording, but you might lose some of your pick attack and presence. This is the low gain setting, which shows pretty similar behavior to what we saw before. except you are getting a lot of this presence as you increase the volume because of that weird nonlinear behavior we saw in those other graphs. But we do see the same type of trend with the low mids. It's just not quite as predominant as the high gain settings. Seems to be behaving a little bit more steady compared to the high gain stuff. Clearly, a lot of changes in the frequency domain. What about compression artifacts? So in this next section, we're going to look at two different practical indicators for seeing the effects of compression, which are going to be crest factor and this thing called envelope spread. For those of you that don't know, crest factor is just the difference between the peak level and then the average level of a signal. So higher crest factors are going to have more transient punch, whereas lower crest factors are going to be more dense. So when we're looking at the crest factor, which is these blue bars, we are going from like 12.5 dB crest factor all the way down to 7.1 dB. That's a big difference. That's a lot of compression. That tells us that these high volume settings are actually shaving down our peaks and making the guitar performance much more dense. But notice it does seem to change when we get to that max volume. And that's important to remember because guitar amps don't act linearly. At max volume, you're likely going to get a change in character of that amp again. And looking at the high gain settings, we see a similar trend. We see that as you increase the volume, we get more and more compression. And then at max volume, there's actually this weird recovery. So again, this nonlinear behavior, but the trend is consistent. The louder you go, the more compressed your guitar tone. Now, this is the envelope distribution of the entire guitar performance for the high gain setting. The wider that you have this spread means that you're going to have a bigger difference between the quiet parts, the body of the note, and then any of the peaks or transients that come from like a pick attack, for example. If the spread is more narrow, meaning that these curves become steeper and steeper, that means the sound is going to be much more compressed and controlled and accelerates to its max volume or max waveform amplitude fast. Another way to think of these plots is imagine that you are plucking a guitar string. The more variability between that pick attack and where the body of the note is being sustained and how it fades makes these plots wider and wider. If you have something that is very compressed so that there is no more pick attack, so when you pick your guitar string, it just goes to max amplitude and it holds there because we're doing so much compression, and then all of a sudden it just falls off, you're going to have a very narrow envelope distribution that almost looks like a square wave, and that tells us that the guitar string or the amplitude of the guitar signal either lives at max volume or no volume. I hope that makes sense to somebody. It's kind of a complicated thing. So knowing that, this just shows us that we have, for max volume, a much steeper slope here on this curve, so that's going to give us more compression than these other volume levels. And if you're curious about the envelope distribution for the low gain setting, that's what it looks like here. So this one's a lot more obvious. We don't get a lot of compression until we hit that max volume. Then we get a dramatically narrower envelope distribution. So lots of compression coming out of those power tubes. Most likely driving this into some sort of clipping because this is a very asymmetrical envelope. So now we've seen differences in frequency and also compression. What about harmonic content? Now, this is a little bit trickier to explain because traditional harmonic analysis is done using pure sine sweeps and tones. That's not what I wanted to do because it's not representative of actual guitar performance. So I'm going to do my best to try to show you a musical indication of the presence of additional harmonics and saturation in the signal in these next few plots. This graph compares the energy above 2 kilohertz to the energy below 2 kilohertz. And I'm using this as a musical proxy to understand what's going on to the upper harmonics, the pick, attack, and fizz that is in our guitar tone. Now, this is not, like I mentioned, a formal total harmonic distortion or THD measurement. It does not prove that one is less saturated than the other. We're just using the change in the frequency content as a proxy for how much distortion and harmonics are being added to the signal. At low volume, this tells us that because we're going in this direction, that the tone is inherently darker than it is brighter. And then as we increase the volume of our output stage, it's getting darker and darker. So the high volume setting, so at 75% volume, is the darkest tone that we were able to get in this low gain setting. And then by cranking it to max volume, something weird happened again in the amp, and now we are getting a brighter tone than when we started, possibly due to additional saturation and harmonics that are being generated. So you can think of this increase in brightness overall as a stronger pick attack, maybe more fizziness in your guitar tone, and then also more bite. All right, check out the high gain. So this is telling us that the high frequency and low frequencies are much closer together in the high gain settings, which makes sense, right? Distorted guitars are kind of sizzly and fizzy. And as we push the output stage, what's happening is we're actually getting a darker and darker tone, and it kind of maxes out at the high volume setting, right? We're feeding the power amp with a heavily distorted signal already, so that kind of makes sense why it would probably be about similar and kind of top out early. So again, big differences in tone here, especially when we have a distorted guitar. So if you have a tube amp and you might be wondering why your high volume setting sounds smoother, and then when you crank it to max, it sounds hairier or fizzier, this could explain it. I really like this plot because I'm a nerd. But check this out. This is a plot of where the centroid frequency is for the low gain setting. That's basically just like the center of gravity of your entire frequency spectrum. So all the frequencies that you have coming out of your guitar amp, where is the most dense frequency? Where is it the thickest out of the entire guitar performance? That's what we're plotting here. And you can look at just the blue bars. We have a mean spectral centroid at like 330 hertz. As we increase the volume, it's starting to shift lower, so like 320 hertz here. High volume, we're down to like 300 hertz, but then you crank up to max volume and it jumps up to about 370 hertz. That kind of gives you an indication of the spectral density of our guitar tone that's changing as we turn the volume up. Super cool. And then these orange bars are just basically rolling off the ends of the frequency spectrum just as an insurance policy to make sure that if we are missing a lot of high frequency content, that we're not artificially shifting the centroid into different areas. But we see the exact same shifting behavior and pattern, and it matches our mean spectral centroid. So we know it's pretty good. Wait till you see the high gain setting. Check this out. This is bonkers to me. When we go into a high distortion on our amps, now we're sitting at like 200 hertz for the centroid. So the majority of the density of that tone is now living at 2K. And then as we increase the volume, we actually get a loss of our mean spectral centroid to lower and lower frequencies, meaning the tone gets darker and meatier and thicker as we increase the total output volume with a little bit of a shift back at max volume. And again, this is just reinforcing that common theme that we've been talking about where the power amp is nonlinear. And so you do get surprises depending on what the output level is set to. All right, let's jump in and actually listen to the differences of the actual amp signal at those different levels so you can hear how those data translate to actual sounds for your music. And so this is going to help inform your mixing decisions, your tonal decisions when you're trying to dial in good guitar tone. Now that you know that you have these additional knobs that you can play with to either make the guitar tone sound fizzier, smoother, darker, more dense, or if you want to have an increased pick attack, for example. So let's see if we can hear all those things in the different audio files that we have. As a reminder, the analysis was done with the RMS match levels, but for a listening test, in my opinion, I think LUFS matched is a better option to really hear the differences between the different tracks. Okay, so let's start with the low gain stuff, and I'm just gonna switch between low, mid, high, and max volume so you can hear the changes occurring in real time. And again, this is straight from the amp, so don't freak out when you hear that the tone is like pretty abrasive. Here we go. Hopefully you heard that the max volume one had this like fizziness to it that we saw in every single one of those plots. Something interesting that I'm picking up on, tonally, these three sound pretty similar. The biggest differences I'm getting are in the pick attack for the low and the mid volume levels. I can feel the pick attack. It's more dynamic. It jumps out a little bit more, and you can literally see it visually. We see the little jumps in the waveform right here. That extra crust factor from the low and mid volume settings might actually help add back some aggression into the tone, especially if you have a chuggy part that you really want to hammer into that guitar. All right, let's check out the high gain settings now. I'll do the same process. Man, was there a huge drop off in the top end of these guitars just from increasing the volume a little bit, especially from low to mid. Listen to how much the tone just like rolls that top end off. This high volume sounds like an absolute winner in my opinion. But who knows until you actually put it into the mix. Key takeaway here between these two gain settings is that our output section on our tube amps do not act in isolation. Depending on if you have a low gain or high gain preamp setting that then feeds your output section of your amp is going to completely change the tonal characteristics that you get out. And the more distorted the tone going into the output section, at least for my amp, made a huge difference going from low medium level to high and max output level. I covered a lot, but I think there's some really important key takeaways here. The power amp volume knob on our guitar amps is not just for loudness. It greatly changes the frequency balance, the compression, the harmonic density, the overall brightness, and the feel of the guitar tone. And as I showed over and over, it does not change it in a linear fashion. When you start driving your amps too hard, you get very different behavior that may or may not work for your guitar tone or your song. But just knowing that these different regions exist in our guitar amps opens up the possibility of immediately going to an amp, dialing in a killer sounding guitar tone. For example, if you want more density to your guitar tone, push your power section. If you want more pick attack or transient behavior, we saw that we lost a lot of that once we start getting to the high and max level on our guitar amp. So you might want to dial the volume back. If you're curious about what your output section sounds like when it starts really compressing the signal, it might be best to set your preamp gain at a lower distortion level so you can feel and hear how the amp reacts to a more dynamic signal. We saw that when we fed the high gain tone into the power section, that hearing the compression became more challenging because everything's already compressed. Something I was not expecting was how much of the top end rolls off when you have a high gain guitar tone and you start really driving your power output section. That's something that I'm going to take with me anytime I do guitar production in the future because nobody likes a really sizzly, fizzy guitar tone. And I'm super curious, what did you think of this entire analysis? Did it make sense? And let me know in the comments, what was your favorite guitar tone? Was it the low volume, mid, high, or max volume? I know it wasn't going through a guitar cab or anything, but just let me know which one you think felt the best. So dialing in guitar tones is one part of the puzzle. The next step is trying to figure out how to make the tones work for your song. In the description, I have a link to download my free rock and metal mixing cheat sheet. It has a lot of my favorite starting points for how to make all the different pieces of a rock or metal song fit together. I'm Bobby Balo, the mixing and mastering engineer at Rayton Productions. I'll see you in the next video.